Okay, we have a couple more examples to do. In the first one, a brand new car costs $23,400. You're going to put 10% down and finance the rest. Find the monthly payment. If the loan is, let's see, 5.9% interest for 5 years. After finding the payment, we're going to determine how much total will be paid in interest if we take the full 5 years to repay the loan. All right, let's start with the first part of the question, which is actually finding the payment. Remember, any financial problems, the first thing you want to ask yourself is, it's simple or compounding interest. As we skim through the problem, we see that it is compounding interest. Okay. In addition to that, let's see, the next thing we want to look for is it multiple transactions or is it a single transaction? Being that we're making monthly payments, that makes it a multiple transaction. Okay, now that we've determined we're in the multiple transaction cases, which are annuities, we have to determine whether it's growth or decay. Well, repaying a loan is going to cause that balance, that starting balance, to decrease in value, which is considered decay. So as far as the decaying annuities go, we are asked to solve for the loan payment amount, which means we are solving for R. So the formula we're going to use is the exact same formula we used in the previous example. And so I'm just going to recopy it here, and then we'll go ahead and plug in the appropriate numbers. Now we have to be careful when we plug in for P, because you might be thinking it's $23,400, but you're putting 10% down. So you're only financing 90% of that amount. We have two ways to figure this out. We can take 10% of the $23,400, which is $2,340. Reduce the purchase price of the car by the $2,340, and we get our amount that we need to finance. The shortcut of that is, if we're putting 10% down, we're financing 90%. So if we took 90% of $23,400, you get your amount that you need to finance. Okay. Either way, we'll come to the formula and we'll plug in the $21,060 for P. Little r is your interest rate, that's 0.059. M is your number of cycles per year. Monthly payments make it 12. Okay, we can go ahead and just insert these numbers here. Now, as far as N is concerned, N is the total number of transactions. So that's 12 times a year for 5 years. As far as our denominator is concerned, we've already thought about all those numbers. So we can just run through that. Once you run through that on your calculator, take a couple of minutes and do that and check to see. You can pause the video if you'd like, but when all is said and done, you should end up with a payment that is $406.17. Now, after finding the payment, we need to determine the total that will be paid in interest. If you look back at the previous video where we created the full amortization table, if I asked you how much was paid in interest, you could have just went and added up that interest column. Using that method would mean we'd have to create a full amortization table for this. But this amortization table wouldn't just have 4 lines, it would have 60, because you would have a line in your table for each of your payments. Well, to make an amortization table with 60 lines is just way too much time. In fact, you'll never have to make a full amortization table by hand. I'm going to show you a website that you can go to when we meet again in class that will do something like that for you. Nonetheless, without creating the table, we may still want to know how much we're paying in interest. Given all the information we have here, we can actually do that very quickly. Consider your payment of $406.17. That payment is comprised of both the principal and interest. So if we take the $406.17 times the number of payments we're going to make, that will tell us what we paid back in total for the loan, which is $24,370 and 20 cents. Taking away what we borrowed, so taking away the $21,060 leaves us with $3,310.20. Well, the difference between what we pay back and what we borrow is the interest. So we could quickly calculate the interest that was paid on this loan. All right, let's have you try one on your own. A family borrowed $160,000 to buy a house. The loan was for 30 years at 6% interest. It's compounding interest. We're going to find the monthly payment and the total paid in interest. Okay, again, we see it's multiple transactions because we're making monthly payments. How do we know it's decay? Well, when you repay a loan, it decreases in value. And again, we're asked to solve for the loan payment amount. So here's your formula. I would like you to pause the video and take a few minutes to work through this. Not only are you calculating the loan payment amount, but I'd like you to calculate what it is you're going to pay in interest, or what this family would pay in interest over the life of the loan. So pause the video. All right, I'm going to continue working now so that you can check your answer. Plug in 160,000 for P. Our interest rate, we're dealing with a 6% interest rate and monthly payments. So this is what's getting plugged in here. Now our N, this is monthly payments for 30 years, which brings our N to a total of 360. Okay. Just plugging in the correct numbers now down here. This way you can check your numbers. Your loan payment amount, or this family's loan payment amount, should be $959.28 monthly. Using the same technique we did above for the car example, if the family is paying $959.28 monthly for 30 years, they're going to make 360 payments, which means they are going to pay in total $345,340.80 for a $160,000 loan. Which means if they took the full 30 years to repay, they would repay $185,340.80 in interest on top of the $160,000 they borrowed. Note in this particular example, they are paying back more in interest than what they borrowed. If you're not shocked by that, then I'm not quite sure what could possibly shock you. This is astounding, and unfortunately it is the case for a lot of people that they do end up paying back more in interest than they initially borrowed. So in class, what we're going to do is discuss some interest saving strategies. You may not be able to reduce what you borrow, but there are some strategies for reducing what you pay in interest, and that we will discuss in class.